Hello everyone and welcome to our presentation on application of clipper circuits in medical devices. Today, we will explore how these fundamental electronics components play a crucial role in medical devices. Let's begin by defining what a clipper circuit is. In simple terms, a clipper circuit is an electronic circuit engineered to limit or clip a specific portion of an input signal, be it voltage or current, without causing any distortion to the remaining desired part of the waveform. Its primary purpose is to remove unwanted parts of a waveform that exceed or fall below a predetermined voltage level. So, how this circuit achieves its function? At its core, a typical clipper circuit utilizes components like diode, resistors, and a voltage reference. The basic principle is quite straightforward. When the input voltage either rises above or drops below a specific set threshold, the diode within the circuit becomes forward biased. Then the diode conducts electricity, effectively shunting away or blocking the excess voltage. This action clips the waveform, meaning the output voltage is limited to that predetermined level, resulting in a flattened peak or trough in the signal. Now, why are clipper circuits so vital in medical devices? The reasons are rooted in safety, accuracy, and reliability, all paramount in healthcare. First, they ensure patient safety. Medical devices connect directly to patients, so even minor voltage surge pose a risk. Clippers act as a critical protective barrier, safeguarding both the patient and the sensitive biological measurement. Second, they provide crucial device protection. Medical equipment contains delicate expensive components. Clippers prevent damage from unexpected voltage spikes or overcurrents, preserving the lifespan and functionality of vital equipment. Finally, they ensure signal integrity. In diagnostic and monitoring, bioelectrical signals are essential. Clippers shape and clean these signals, removing unwanted noise or interference, which is vital for precise data, accurate diagnosis, and reliable device function.
Hi, my name is Noreen and I will be explaining about the different types of clipper circuits that could be constructed with different configurations of diodes. These different configurations will produce their own unique wave output, consequently being useful in various medical equipment. As you can see in this graph, it displays a basic introduction of what we should know about clippers. Generally, clipper circuits can be divided into two main classes, which is a series clipper circuit and a shunt clipper circuit. In other words, a parallel clipper. These two types could also be further customized by incorporating a direct current source into the circuit. So initially, we have a wave input of a sinusoidal graph, starting from the positive half cycle followed by the negative half cycle. When put through a series or parallel clipper circuit, one half of either cycle will be cut off completely, leaving only the other half of the wave cycle. That is the basic of how series or parallel circuits work. To go into more detail, we first review the first clipper circuit, where the diode is connected in series. The direction of the diode, whether forward biased or reversed, affects which half wave that will be erased. When the diode is in reverse bias, in the positive half cycle, refers to the first picture, the voltage will equal to 0. When it is in a negative half cycle, the input voltage will be equal to the output voltage, producing a full wave. This goes conversely when the diode is connected in forward for the positive half cycle. As for the shunt clipper circuit, we can immediately see that this time, the diode is connected in parallel. Observing the output waves, we can see that this is actually quite similar to the series clipper circuit. But there is a difference. When the diode is connected in forward, in the positive half cycle, the voltage is immediately blocked out. And the contrary goes when the diode is connected in reverse, resulting in a wave output. Now, why are these configurations needed? Sometimes in medical devices, like wireless ones, they require only the positive or negative part of the wave. For example, a muscle contraction monitor. Whether it be parallel or in series. Instead of removing the entire half wave, the direct current source snips only a part of the wave, only allowing a certain maximum voltage, depending on the circuit configuration. Therefore, the configuration of the negative or positive pole of the diode and the battery also plays a part in deciding what the shape of our wave will come out like. Bias configurations are also vital in medical supplies. For instance, in electrocardiogram, there will be external sounds from our body when we are measuring. So the diodes will cut and filter out any unnecessary noise when taking a reading.
The Zener diodes enter breakdown mode and conduct the excess voltage to ground, effectively clipping it and protecting downstream electronics. Sometimes, a series resistor is added to limit current through the diodes. This method ensures that only the useful ECG waveform reach the amplifier, preserving signal quality. Ultimately, the clipper circuit plays a vital role in improving circuit durability, preventing amplifier overload, and maintaining patient safety, especially in a hospital setting where numerous electronic devices operate simultaneously.
Moving on to the next medical device, which is defibrillator. So, what is defibrillator? Defibrillator is a medical device that is designed to give a strong, controlled electric shock to the heart, and it's basically used in emergency cases where the heart is not beating properly, such as during ventricular fibrillation, which is a very fast and irregular heartbeat, or ventricular tachycardia, which is a dangerous fast heartbeat. And the purpose of this shock is to stop the abnormal heart rhythm so that the heart natural pacemaker can take over and restore the heart normal steady heartbeat. So, how does a defibrillator works? Defibrillator works by first being charged up by storing electrical energy in its internal components, such as a capacitor. And the amount of energy that needed is depend on the type of the defibrillator and the patient's condition. And when activated, the defibrillator will release a stored energy in its form of short, high voltage pulse. And this pulse will pass through the heart muscle and stopping the chaotic electrical signal that cause abnormal rhythm. And by doing this, the defibrillator will give the heart a chance to reset itself, and it allows the heart normal to start again and restore healthy heartbeat. Next, we are moving on to the main discussion of this presentation, which is the function of clipper in defibrillator. So, we know that defibrillator will generate high voltage pulse to restore normal heart rhythm. However, this pulse can contain a voltage spike or tension that can damage the internal circuitry or lead to unsafe level of shock, which is very dangerous to the patient. So, the clipper here will limit the voltage to a predefined maximum level by clipping off the excess voltage beyond a safe threshold. This will ensure that only the desired level of electrical energy is delivered to the patient, and it will protect monitoring or control electronic from overvoltage. Now, let's discuss the real-life case studies of failure of the defibrillator. If a defibrillator delivers too high voltage, it can cause a serious harm, which will include the burn on the skin where the electrode touch the body, and it will ruin the patient's skin, and it will also damage to the heart muscle tissue, making the heart more weaker than it should, and it will also make the arrhythmias, which is the irregular heart rhythm, be worse, and it might cause the heart to stop completely or cause other organs to be affected in these rare cases. And voltage is too low, the shock may fail to reset the heart rhythm, which means the defibrillator will not save the patient and could lead to death. So let's reflect again why clipper is significant to the defibrillator. So clipper circuit are crucial for safety because they will limit the maximum voltage that can be sent by the defibrillator. And they also prevent harmful voltage spike from reaching the patient, and it will make sure the shock stay within a safe and effective range. And by stopping the excessive voltage, the clipper will protect both the patient from the harm and the internal part of the defibrillator, so the defibrillator won't get damaged. So the clipper circuit will also help defibrillator meet the international safety standard, which ensure the medical equipment work safely and effectively. Without a reliable voltage limiting the circuit like clipper, defibrillator will be too dangerous to be used on the patient.